Welcome to this explainer. Okay, let's dive right into this epic tale of a programming kingdom to explore one of the most absolutely fundamental concepts in computer science. We're going to look at exactly why our programs forget things, and more importantly, how we can teach them to remember. Look at this vibrant, peaceful town of Pythonia. You've got a baker pulling fresh bread from the oven, a scholar taking detailed notes, kids playing. Now, in the programming world, this perfectly represents the execution phase. While your code is actively running, everything just seems, well, incredibly useful. Variables are holding their values, calculations are firing off exactly right, and your application is doing exactly what you designed it to do. It feels like magic.
Section 1. The Curse of Pythonia, a kingdom with a secret.
But suddenly, there's panic in the streets as the clock strikes midnight. This dark purple fog rolls in, and literally nothing is saved. Everything done that day is completely lost. In our analogy here, midnight is that exact moment your program stops running. Whether the code finishes its final line or you just hit the close button, the reset happens. All that beautiful complex data you just generated, poof, gone into the digital ether.
So, breaking out of the fairy tale for a second, let's hit the hard technical fact behind this. Pythonia's curse is actually volatile memory. When a program runs, it lives in a very specific part of your computer's brain, the RAM. Now, RAM is incredibly fast, which is exactly why the kingdom thrives during the day, but it's entirely volatile. That means it absolutely requires active power and an active program to hold on to its information. The absolute second that program terminates, the memory is dumped. It's kind of like having a brilliant thought, but the moment you stop concentrating on it, it's completely erased from your mind forever.
Section 2. The Midnight Reset, when programs stop.
Notice how all those letters, numbers, and musical notes are just vanishing into thin air the moment the program stops. Our young hero here, Byte, is desperately trying to close his book to trap the magic inside, but he just can't. The data slips right through his fingers. And you know, this is exactly what happens to your variables, your lists, and all your user inputs when a script finishes. The computer reclaims that memory space for other tasks, sweeping away your data like it never even existed.
Because nothing is saved, the real-world impact on Pythonia is just tragic. Bakers forget the amazing new bread recipes they invented that very morning. Scholars are looking at totally blank pages where their hard-earned knowledge used to be. I mean, even friendships reset every single day. Think about this in the context of an application. Imagine playing a video game for 10 hours, or typing a huge essay, and the literal moment you close the window, your progress is totally wiped out. Every time you open the program, you're starting from square one. It's an incompletely unworkable situation.
Section 3. The temporary console, the illusion of memory.
Notice the glowing keyboard and that floating terminal window. When you interact with a program, you're giving it input. Maybe you're typing in a recipe or a password. Your computer CPU processes it, and the RAM holds it temporarily. It even gives you an output right there in front of you, so it genuinely feels like the computer has learned something. But here's the catch. The console is essentially a mirage. It's just a temporary display window. The moment you close it, the input and the output just vanish, exactly like that magic fog rolling through Pythonia.
So we've got a pretty stark contrast here. On one side, you have the keyboard and console. Sure, they're interactive, they're super fast, but they are highly temporary and volatile. They belong only to the present moment. On the flip side, we have files. Files are the absolute bedrock of permanence. They completely bypass the volatile RAM and write your data directly onto your computer's hard drive or solid-state drive. Basically, a file takes the fleeting thoughts of a running program and carves them right into digital stone.
Section 4. The quest for permanence, seeking a solution.
Byte is looking at his empty hands and asking the fundamental question that literally every single new programmer eventually screams at their computer screen. Why does the data keep slipping away? It's so incredibly frustrating to write a program that asks the user for their name, their age, their preferences, only to have the program completely forget who they are the very next time it runs.
But look at Byte's pure determination here. You can literally see the magical energy swirling around him. He is flat out refusing to accept the reset. He realizes that if he's putting all this effort into learning and creating, that data must have a way to stick around. And honestly, this is the exact mindset shift every developer goes through. You move from writing simple scripts that just kind of do a trick and then vanish to writing robust software that leaves a lasting footprint. You stop accepting volatility and you start demanding permanence.
Section 5. The file storage breakthrough, file handling.
Guided by a wise mentor, Byte discovers the ultimate magical breakthrough. See him walking confidently down that glowing path beneath the stars? He isn't running from the fog anymore. He's found the permanent storage solution, file handling. By learning how to read from and write to files, Byte has finally found a way to take the volatile magic of the day and safely lock it away before the midnight reset even hits. His recipes, his books, his progress, they're all safe now.
Okay, so let's recap the absolutely crucial takeaways from Byte's journey. Why do we actually need files? Well, first off, it's the only way to overcome the curse of volatile memory. Second, file handling ensures that your data actually exists long after the program officially ends. Third, it completely prevents the loss of user inputs in daily computing effort, so no more starting with a blank slate. And finally, it creates a true permanent storage solution on your hard drive. Files are basically the bridge between a temporary action and a permanent legacy.
Armed with the breakthrough of file handling, it's time for you to start building your own permanent legacy in Python. You've seen what happens when you rely solely on volatile memory, right? You've seen the absolute tragedy of the midnight reset. But now you have the key. So as we wrap up this explainer, I want to leave you with a thought. Now that you know the secret to permanence, what are you going to save first in your files? Will it be a high score, a database of users, maybe a recipe of your own? The kingdom of your code is waiting for you. Keep learning, keep saving, and I'll catch you in the next one.